Assalamu alaikum warahmatullahi wabarakatuh. Hello students, I hope that you are fine and doing well. Today we will cover experiment number 5 in your lab manual related to push button speed selection controller to control an wound rotor induction motor. Let's move for the second slide to continue explaining. When we end up with this exercise, you are expected to be able to construct and troubleshoot the circuit of wound rotor induction motor in which push button speed selection controller is employed. For the discussion, we will see that most of the components are explained in this discussion are coming in slide number 4. So just either you read it or move to slide number 4 because all the components will be covered in slide number 4 in details. In this slide, we will see that the normal operation have been written in here. Take your time, read it, and when you finish, just move to the next slide. Now let us talk about the construction of the circuit. We have a stop push button to stop the whole process, and we have 3 start push buttons, one of them for low speed mode and the other one for medium speed and the last one for high speed. We have 3 contactors, or 2 contactors actually, CA and CB for accelerating or acceleration, and we have M starter, which is provided with overload for protection. Let's move step by step in here and say that we are pressing low speed push button. What will happen? The normally open contact in the control circuit from M contactor will close for holding, and the 3 normally open contacts in the power circuit will close to connect the stator circuit of the motor to the power supply. And by that time we will have the motor running at low speed because the resistors connected to the rotor circuits are still in place and they are not being shorted. And that's going to lead the motor to run at low speed because the induced voltage in the rotor circuit is not fully applied to the winding itself. Part of it has been dropped through the resistors. When we press the medium speed push button, CA will energize, and CA1 normally open contact in the control circuit will close for holding. CA2 and CA3 normally open contacts in the power circuit will close. This will short circuit the 3 resistors on the right side. And when these 3 resistors are shorted, more voltage will be applied to the rotor windings. And when more voltage is applied or induced in the rotor windings, this will lead the motor to run in higher speed because higher voltage is there. When the high speed push button is pressed, CB coil or contactor will energize, closing its holding contacts, CB1 in the control circuit, and the 2 normally open contacts, CB2 and CB3 in the power circuit. This will short circuit the rest of the resistors, and the full voltage induced will be applied on the winding of the rotor circuit. By this case, we will have the normal speed or the full speed of the motor. Well, in your lab manual, you will find question number 1, or sorry, number 4, number 5, and number 9 to be answered. The answer for question number 4, using the tachometer, the speed was found to be 1740 RPM. And for question number 5, it was asking if there was a noticeable speed when we move from medium to high speed. Of course, there is a noticeable speed variation because we are shorting the resistors connected to the rotor circuit gradually, and that's inducing much more voltage on the rotor circuit. And for question number 9, after adding load, again the same process we have done it in question number 5, but under load, and again the speed variation still exists even the load is being added to the circuit or to the motor. Now let us come to the troubleshooting report. The fault description is that when the low speed push button is pressed, the motor starts in low speed normally, and when the medium speed push button is pressed, the speed of rotation doesn't change, and when the high speed push button is pressed, motor moves from low speed to high speed, or in other words, the medium speed mode doesn't work, and the rest of the operation is fine. Let's put some initial conditions in order to obtain the troubleshooting. The first thing, as we don't have a short circuit, we are allowed or we are supposed to go for the online troubleshooting using the voltmeter, of course. Let us put one more condition, is that all readings taken are taken when the medium speed push button was pressed after the low speed push button, of course, while the high speed push button is not pressed. Now, let's take some readings to just verify what's there in our minds. Let me tell you the truth. In my mind, I can locate the fault before doing the troubleshooting because the fault description gives us some keys to locate the fault location. It was said that when we press the low speed, the motor runs in low speed normally. When we press the medium speed, the motor doesn't go to the medium speed. But when we press the high speed, motor moves from medium speed, or from low speed actually, to high speed immediately without passing through the medium. This means that in the control circuit we are fine because this is the sequence. We can operate the low speed, then medium, then high, and this is what we have done it. But the only issue is that the medium speed doesn't work. This means that we have some issue in the control circuit and not in the power circuit and not in the control circuit. Let us take the first reading across the contactor CA to make sure that it is energized. The normal reading across this contactor is to be 127, and when we come practically and find it 127, we will say that initially it is energized. Let us take one more reading across the normally open contact of CA2 and see the result. The result for this contact when it is energized, it should be 0 volt. When we come and find it more than 0 volt, it means that this contact did not close. We will take one more reading across CA3. If we find it more than 0 volt, again it means that the contact did not close. Let us take one more reading just to make sure that the contactor is energized across the holding contact. I'm sure it should be 0, and it will be 0, not it should be, because we can operate the high speed mode, and we cannot operate it unless the medium speed mode is running. And to have it running, the holding contact should be with us, because we just pressed and we are not keeping pressing the push button. Across that contact, we come practically and find it 0. It means that the contactor is energized. Our conclusion from these readings is that there is a poor conductivity on the two normally open contacts on the power circuit CA2 and CA3. When the fault is cleared, the circuit should work normally. If you notice, just a while when we have done the troubleshooting, we went through 5 steps approach to do the troubleshooting. The first one is to observe the fault description, to focus on the fault description itself and observe where is the issue in that description. The second step, which is to find the problem area, and we just decided from the beginning that we have the problem in the power circuit and not in the control circuit. The third step is to identify possible causes, and we initially said that it might be from the contacts of CA contactor. And the fourth step is to determine most possible cause. The most possible cause was the contact itself and not the contactor. And the last step, or step number 5, is to do the testing, just to confirm that our estimation was fine. One more time, let's see the scenario we just had it before, during the fault. When the low speed push button is pressed, M contactor is energized, and the holding contact M1 in the control circuit is closed for holding, and the 3 normally open contacts in the power circuit are closed, powering the motor. And when CA, or medium speed push button, is pressed, CA is energized, closing its holding contact in the control circuit, while in the power circuit, if you see, CA2 and CA3 are not closed. And this is the case we just had it during the fault. Finally, when the high-speed push button is pressed, CB is energized, closing its holding contact in the control circuit and shorting the 2 contacts in the power circuit and providing us with the high speed. Out of this exercise, we came out with this summary. The push button speed selection is used to manually control the accelerating speed of wound rotor induction motor. And there is one more application for the contactors, which is to use them for accelerating, not only for connecting the power to the motor. No, we can also use them or utilize them to change the connection to have different speeds. Just to conclude this exercise, some questions have been made for you to test your knowledge. Please take them seriously, answer them, and keep records for yourself because you may need them in the future. Now start reading them from question 1 to question number 6, and you can keep an answer in a separate paper. Take your time during answering. Thank you, and I wish you a good luck.